All right, so here's our first example of a new strategy for solving systems called elimination. So far we've done solving systems by graphing, by substitution, and then this one's called elimination. All right, so here's the idea. Take a look at our system here. What we want to do is the same goal as the other methods. We want to combine these two equations together to get an answer. And more specifically, what we want to do is we want to combine these in a way that we go down from two equations with two variables down to one equation with only a single variable, either x or y. Okay, so the only difference between this and the previous lesson is just the method that we use. The goal is still the same, find x and y by combining these equations together. All right, so here's why they call it elimination. The first thing you want to do is you want to look at these equations and see, does everything line up? Because that's important. What we're going to do is we're going to treat this like an addition subtraction problem where you line things up by place value columns, except instead our place value columns are these terms. So what I'm looking for is that, do all the x's line up? Yes. Do the y's line up? Yes, they have their own columns. This is important too. The equal signs have to line up as well, and then just all the numbers on the other side. Okay, so this one is ready to go using elimination. So that checks out. Now, the other thing we're looking for is, in this problem, does one of those columns, the items in the column, the terms, do they match up? Okay, well, if you look here, the one I'm talking about is this one. Now, even though they're opposites, we have negative 5x and positive 5x. This is what we're looking for, some kind of set of matching terms, or maybe opposite terms in some cases. So that one's good to go too. Okay, so this is where we should focus our attention. This is the important column. Now, here's why we call it elimination. What we want to do is we're either going to add or subtract these two entire equations together, but with the sole purpose of getting rid of or eliminating all these x's. All right, so what you do is over here, you're going to put a big circle so you remember what you're focused on. And you're going to say to yourself, all right, what should I do to combine negative 5x and positive 5x so that they will vanish? Should I add them together or should I subtract them? Okay, in this case, the choice is to add them, because when you take something plus its opposite, they cancel each other out. So negative 5 plus positive 5 becomes 0. Okay, let's say I hadn't done plus. If I had done minus, that wouldn't get me where I wanted. Negative 5x minus 5x would be negative 10x, and I haven't eliminated anything. The purpose here is to take whatever matches and choose the right addition or subtraction move to make these vanish. Okay, so in this case, it's addition. Negative 5x plus positive 5x cancel each other out, and we get 0x, or just nothing. So I'm not even going to write it. These just disappear. Okay. Now, what I do is I carry that through the rest of the problem, again, like these are place value columns. So think of this plus as a positive, positive 2y. And then here's why we circled this. You always have to go back to the operation you chose. So positive 2y from the top equation plus positive 1y from the bottom equation makes that positive 3y. Equal signs need to drop down. That's why they have to line up. And then again, this is why you circle it really big, because even over on the right, you have to come back to the plus sign. So 13 plus negative 1, 13 plus negative 1 is 12. All right, and so we eliminated a good portion of it, but we got what we want. This is the same goal as in substitution. We combined two equations together with the intention of getting one equation and one variable, because this we know how to solve. Divide by 3, divide by 3, so y equals 4. All right, so that's half my answer right there. X is something we haven't figured out yet, but y is 4. All right, so now the rest of this you'll like, because it's no different than how we finished off substitution. This becomes a substitution equation that we can use, and all we have to do is plug it back into either original problem. All right, so I'll put this work in red. Now again, you can pick either one, so pick the one that's easier. I'm thinking maybe this bottom one. The numbers look smaller. I could have picked the top one, it wouldn't make a difference. All right, so I do what this substitution is telling me to do. It's telling me everywhere I see y, swap it out and swap in its equivalent. So I do 5x plus y equals negative 1. All right, so now we do what this is telling us to do is y has been swapped out, we swap in 4. All right, and this again, we can solve this. 5x plus 4 equals -1. So first thing we do is get rid of the plus 1 by subtracting. I get 5x equals -5. Then to get x by itself, divide by 5. So x equals -1. So that should be our solution to the system. X is -1, y is 4. All right, so to double check, make sure we did it right, we check our answers. Okay, and this is no different from the other stuff. You take both equations one by one. I'm going to take the top one, put it in blue, and we just plug in our numbers and see if they work. So -5x plus 2y equals 13. X is -1, y is 4, plug them in. -5 times -1 is +5, 2 times 4 is 8, and 5 plus 8 does equal 13. So it works for the one in blue. All right, let's take this bottom equation, which I'll put here in red. So 5x plus y equals -1, and plug in the same two values. X is -1, y is 4. Do the math. 5 times -1 is -5 plus 4. -5 plus 4 is -1, which equals -1. So that checks out too, and so we know we did it right. This is the solution to the system, or once again, going back to our first lesson, if we were to graph these two equations, this is the point at which these two lines would cross. It's the solution to the entire system.